Chapter 008 8.2 Probability 02 Assistant. Professor Dr. ch08 contact info. supan@hotmail.com. Reference Chapter 6 Probability. Professor Peck. Topics. 1. What is probability? Theory of probability is a branch of mathematics which has been developed to deal with situations involving uncertainty. 2. Review set theory. Set, subset, union, intersection, difference of sets. 3. Terminology of probability. Sample space, simple event, complicated event. 4. Calculation of probability. We calculate some events. We calculate probability of an event. 5. Probability using R. We install the probs package. We then calculate probability using command from this package. We continue topic number 4 and finish topic number 5. Learning objectives of week 8, 9. Students will be able to identify the sample space for a given chance experiment. Calculate the probability of events, including events that are the union of, the intersection of, or the complement of other events. Interpret a probability in context as a long-run relative frequency of occurrence. Calculate conditional probabilities. Distinguish between discrete and continuous random variables. Construct the probability distribution of a discrete random variable. Compute and interpret the mean and standard deviation of a discrete random variable. 8. 1. 4 basic properties of probability. The view of a probability as a long-run relative frequency that can be approximated empirically has some limitations when it comes to calculating probabilities in real life. The most obvious problem is time. If computing probabilities, even for simple chance experiments, were to require hundreds or thousands of observations, even the most ardent statistics students would avoid this task. An alternative approach that simplifies things in some situations is to study fundamental properties of probability that can be used to find probabilities of complex events. These fundamental properties are given in the accompanying box. A discussion of each property follows. Theorem 1.1. If event A1 less than event A2, then probability of A1 is less than or equal probability of A2, and probability of A2, A1 equal to probability A2, probability A1. Theorem 1.2. For every event A, the probability of A is more than or equal 0.0 and less than or equal 1.0, such that a probability is between 0.0 and 1.0. Theorem 1.3. Probability of empty event is 0. Therefore, the impossible event has probability of 0. Theorem 1.4. If event A ply is the complement of the event A, then probability of event A ply is equal to 1 minus probability of event A. Theorem 1.5. If event A equal event A1 union event A2 union others events until event AN, where event A1, event A2, until event AN are mutually exclusive events, their intersection is empty set, then probability of A equal to the summation of all events. Probability of A equals probability of A1 plus probability of A2 plus others plus probability of AN. In particular, if event equal to sample space S, then probability of A1 plus probability of A2 plus others plus probability of AN equal to 1. Theorem 1.6. If A and B are any two events, then probability of a union B equal to probability of a plus probability of B minus probability of A intersection with B. More generally, if A1, A2, A3 are any three events, then probability of a 1 union A2 union A3 equal to probability of a 1 plus probability of A2 plus probability of A3 minus probability of a 1 intersection with a 2 minus probability of A2 intersection with a 3 minus probability of a 3 intersection with a 1 plus probability of a 1 intersection with a 2 intersection with A3. Theorem 1.7. For any events A and B, probability of A equal to probability of A intersection with B plus probability of A intersection with B ply. Theorem 1.8. If an event A must result in the occurrence of one of the mutually exclusive events A1, A2, A3, others, until AN, then probability of A equal to probability of A intersection with a 1 plus probability of A intersection with a 2 plus, others plus, until probability of A intersection with AN. In the resting slides, student will learn how to calculate the probability by using these properties. Example 8. 1.13 properties of probability 01. If a single fair six-sided die is rolled, find the probability that it is lower than a 7. Solution in this case, the sample space S is set of 1, 2, 3, 4, 5, 6, and the number of element of SI is 6. Let it be the event that the roll is less than 7. Therefore, event A is a set of 1, 2, 3, 4, 5, 6. This means number of element of A is 6. So probability of A is the number of element of a divide by the number of element of S equals 6 divided by 6 is equal to 1.0. Example 8. 1. 14 properties of probability 02. If the probability that the San Francisco 49ers win the next Super Bowl is 0.4, and the probability that the Green Bay Packers win the next Super Bowl is 0.25, find the probability that the 49ers or the Packers win the next Super Bowl. Solution, let it be the event that the 49ers win, and let B be the event that the Packers win. Are these two events mutually exclusive? Yes, because only one team can win the next Super Bowl. Probability of a union be equal to probability of a plus probability of B, equal to 0.4 plus 0.25 is equal to 0.65. The probability that the 49ers or the Packers win the next Super Bowl is 0.65. By using theorem 1.5, the student will get an A on the history exam is 0.25, and the probability that he will get AB is 0.35. Find the probability that Joe gets AB or better on the history exam. Solution, let it be the event that Joe gets an A, and let B be the event that Joe gets AB. Are these events mutually exclusive? Yes, because Joe cannot get an A and AB on the same exam. Probability of a union B equal to probability of a plus probability of B equals 0.25 plus 0.35 is equal to 0.6. The probability that Joe gets a B or better is 0.6. By using theorem 1.5. Example 8. 1. 16 properties of probability 04. If the probability that it rains today is 0.35, find the probability that it does not rain. Solution, let R be the event that it rains today. Probability of R is 0.35. Since we are interested in the complement of event R, we can apply the theorem 1.4, the complement rule. Probability of reply equal to 1.0 minus probability of R is equal to 0.65. The probability of no rain today is 0.65. By using theorem 1.4. Example 8. 1. 17 properties of probability 05. The probability that a foreign visitor to California's Central Valley will visit Sequoia Park is 0.15. And the probability that a foreign visitor will visit Yosemite is 0.22. The probability that the foreign visitor visits both Sequoia Park and Yosemite is 0.08. Find the probability that a foreign visitor to California's Central Valley will visit Sequoia Park or Yosemite. Solution, let A be the event that the visitor goes to Sequoia Park, and let B be the event that the visitor goes to Yosemite. Probability of A equals 0.15 and probability of B equals 0.22. We also have the probability of A intersection to be equals 0.08. Now use the general addition rule, theorem 1.6. The probability of a union B equals probability of A plus probability of B minus probability of A intersection to be equals 0.15 plus 0.22 minus 0.08 is equal to 0.29. Therefore, probability that a foreign visitor goes to Sequoia Park or Yosemite is 0.29. Example 8. 1. 18 properties of probability 06. Let A and B be events with probability A union B equal 3 divided by 4, probability of A apply equal to 2 divided by 3, and probability A intersection B equal 1 divided by 4. Find A, probability AB, probability B, and C. Probability A intersection B apply. Solution A. Because of probability of A apply equal to 2 divided by 3, therefore, probability of A equal to 1 minus 2 divided by 3 is equal to 1 divided by 3. B. From property of theorem 1.6, probability of a union B equal to probability of A plus probability of B minus probability of A intersection with B. Therefore, we have 3 divided by 4 is equal to 1 divided by 3 plus probability of B minus 1 divided by 4. So we have probability of B equals 3 divided by 4 to 1 divided by 3 plus 1 divided by 4. Equal 1 minus 1 divided by 3 equal 2 divided by 3. C. From theorem 1.7, probability of A equal to probability of A intersection with B plus probability of A intersection with B ply. Or probability of A intersection with B ply equal probability of A minus probability of A intersection with B. Equal to 1 divided by 3 minus 1 divided by 4 equal 1 divided by 12. Example 8. 1. 19 properties of probability 07. Find the probability of a 4 turning up at least once in 2 tosses of a fair die. Solution, let A equals event for on first toss, B equals event for on second toss. Then a union B is the event for on first toss or 4 on second toss or both. Equals at least once. Equals event at least one 4 turns up. Events A and B are not mutually exclusive, but they are independent. From Theorem 1.6, we have probability of a union B is probability of a plus probability of B minus probability of A intersection B equals probability of a plus probability of B minus the product of probability of A and probability of B equals 1 divided by 6 plus 1 divided by 6 minus 1 divided by 6 mutably 1 divided by 6 equals 1 divided by 3 to 1 divided by 36 equals 11 divided by 36 plus 1 divided by 6. Example 8. 1. 20 properties of probability 08. Car choices. A large auto center sells cars made by a number of different manufacturers. 3 of these manufacturers are Japanese: Honda, Nissan, and Toyota. Consider a chance experiment that consists of observing the make and model of the next car purchased at this auto center. The outcomes in the sample space would then be simple events such as Nissan Altima and Toyota Prius. Solution: let's define events E1, E2, and E3 by E1 is Honda, E2 is Nissan, and E3 is Toyota. Then, based on several years of sales data, the probabilities of these 3 events have been estimated empirically as probability of E1 equals 0.25, probability of E2 equals 0.18, and probability of E3 equals 0.14. Because E1, E2, and E3 are mutually exclusive 1. By using Theorem 1.6, probability of E1 union probability of E2 union probability of E3 equal probability of E1 plus probability of E2 plus probability of E3 equals 0.25 plus 0.18 plus 0.14 equals 0.57. 2. By using Theorem 1. For the probability that the next car purchased is not made by one of these 3 manufacturers is probability of not E1 union E2 union E3 equal 1 minus 0.57 equals 0.43. 8.1.5 Probability calculation. Implement probability calculation. Example 8. 1. 21 probability. Steps 1. Create new project. 2. In this example, we will install a probs package. 3. Add our file into project. 4. Type code to plot graph. 5. Run our code. 1. Create new project. 1. Open our studio. 1.1. Go to menu file, then select new project. 1.2. Select new directory. 1.3. Select new project. 1.4. Type directory's name, MBA 601ch08. 1.5. Press the create project. Put this project on desktop. 2. Install probs package 1. 2. 1. Click on the Packages tab. 2.2. Click on the Install tab. 2. Install ggplot package 2. New window, Install package panel, appears. 2.3. Type package name in text box, problems 2.4. Click on the Install button. 2. Install ggplot package 3, or install the package for a few minutes. 2.5. Tick on the small box in front of the package named Problems. Finally, we have got the package. 3. Add our file to project. 3.1. Add new or file to our project by pressing the second plus sign and select our script. The new file name text box appears. 3.2. Type a new file name. ch08.1.22 probability.rn text box. 3.3. Press OK button. Line number 1 sharp load package. It is comment line. Line number 2 library ggplot2. Line number 3 library probs. Line number 4, line number 5 sharp, we toss 4 coins simultaneously the sample space with 16 data. It is comment line. Line number 6 coin 4 less than minus sign toss coin times equals 4. Line number 7 sharp probability of head. It is comment line. Line number 8 coin prob less than minus sign sum. Row sums coin 4 equals head more than 0. Divide by row coin 4. Line number 9, line number 10 sharp, we rolling 2 dice simultaneously the sample space with 36 data. It is comment line. Line number 11 die 2 less than minus sign roll die times equals 2 make space equals true. Line number 12 sharp, make event x1 equals x2. It is comment line. Line number 13, a less than minus sign subset, die 2, x1 equals x2. Line number 14 sharp, make event x1 plus x2 equals 8. It is comment line. Line number 15, be less than minus sign subset, die 2, x1 plus x2 more than equal 8. Line number 16 sharp, probability prob. It is comment line. Line number 17, a less than minus sign prob A. Line number 18 prob B, less than minus sign prob B. Line number 19, line number 20 sharp, a pack of cards contains a set of 13 cards of the 4 suites. It is comment line. Line number 21 sharp, club, spade, heart, and diamond. It is comment line. Line number 22 sharp, each suit contains cards labeled ace, 2, 3, 10, jack, queen, king. It is comment line. Line number 23 card, less than minus sign cards. Make space equals true. Line number 24 sharp, make event only heart and number between 7 to 9. It is comment line. Line number 25, H equals subset, card, suit equals heart. Line number 26 are equals subset, card, rank percent and percent 7 to 9. Line number 27, I less than minus sign intersect, HR. Line number 28 sharp, calculate probability. It is comment line. Line number 29 prob card, less than minus sign prob I. You may pause video. When you complete typing our code, please press the save button. 5. Run our code by pressing Ctrl plus Alt plus R simultaneously. To run code, you can see results in the right-hand side panel. You may pause video. Here is the result of the probability calculation. A, B, H, IRR events. Sample space are a pack of cards. Toss 4 coins simultaneously and rolling 2 dice simultaneously. Finally, we have result. The probabilities Cohen prob, prob A, prob B, and prob card. Thank you MBA 601 Data Analysis and Statistical Computing